Hello again. So in the last live videos, I was doing something basically uh, creating some tensors and doing some training loops using NumPy and then using PyTorch. So we had that done. Okay, so I have ported all the code from Google Code, Google Colab to my VS Code so that I can actually debug and show you what really goes on inside the code, right? We're gonna have a recap right now, and then we will go and learn some new topics, right? So I have started my debugger, and let's start debugging. So I will just recap from the top, basically what we have and what we're gonna do. Okay, so we have this numpy imported, and we are setting the true values of the weights, that is bias and weights is 1 and 2, and the number of samples in our data set, that's 100. And now here, that is where we are creating our data set with a relationship that is y equals to mx plus c, right? Because it's a linear model that we are trying to create, a simple linear regression, right? And we are shuffling the indices and splitting the splitting the data into training and testing sets. I think I don't need to tell you what that means. So we have this data of 100, we are splitting it. 80 goes into the training part and 20 goes into the validation part right now. Okay, goes in, splitting is done. Okay, so we have this model configuration. Okay, the first model configuration that we have is basically we are taking all the numpy arrays that was generated by uh, these guys, and we have split them into training and testing set, training and validation set, and we are now converting them into PyTorch tensors from NumPy array. That's what's happening here. As tensors, we have to take the NumPy and make it into a float and also put it into device. What it means is if you have a GPU, then it will use CUDA, and if you don't have a GPU, then it will use CPU. Okay, and that's done. So we have the first model created. So few configuration is there, like let me just go through them. So our model is from a sequential module from PyTorch, and then is imported from PyTorch. Okay, and this is your sequential module. If you want to see, you can have the documentation as well. So module will be added to it in order to their pass is a constructor. Okay, so there are many functions inside it that you can directly use. Okay, so a lot of stuff happening here, and you have the linear model. Let's go and see what linear model is. So linear model is basically a simple node. If you essentially, what it means is, if as the input is 1 and 1, see, as the input is 1 and the output is 1, if I hover over it, you can see what kind of function it takes in, right? um, you come here and see for yourself, like the arguments, the in features and the out features, the size of the input samples and the size of the output samples is what it takes. So in our case, our n dot is taking in what 1 and 1, which is the input is 1, just one x is coming out and one out is going. Okay, so y hat, that is basically this means. Okay, um, and you can see the implementation as well. I know the real actual calculations might, it's actually written in C, right? The what do you say, PyTorch, so you won't see exactly what's happening there. Okay, um, I guess there are some initialized little parameters. We have worked with this. You can actually set your parameters like this. So it's doing all that stuff. See, then whatever you passed in. So here one would go in and a empty list with out and in, and everything will happen right inside. You can also go and see for yourself how this thing work. One more, I think this function is probably one of the most important modules from PyTorch. That's called F. I will show you where it is, probably at the top somewhere. See, functional import F. You can go here and check for yourself what that is. This is a big function with a lot of functions already defined which are used. See, so basically it's like a CUDA, or what you call abstract classes in a sense, you know. Okay, that's fine. So we are back to our model. That is, our model is defined as this one neuron kind of a model. Okay, okay, okay. Let's go. we are also setting in the optimizer. So we are using SGD, that is stochastic gradient descent. Gradient descent is the algorithm that we use to minimize the loss of our functions. Okay, and then we are also defining the loss function. Just so you know, these are all callable functions. These are what we call a higher order function. What it means, there's a function inside a function, and see the as loss fn is equals to this, so it is not a, this is also a callable function. That is loss underscore fn is also a callable function in itself. So that is what we call a higher order function. We'll probably get into that in some time, or I guess we all know if you have the basics of Python. Basically, it's in a sense you have a definitions. The function is there, function 1, and again inside that you have another function 2, and you return that some value from here. Okay, and also you return from here. So it will look something like that, like something is returned from this function, return, and then here also returned. So in this case, you see this MSE loss, so it will be just something like this, def of MSE loss, and then inside you will have another function which will take. So here if you see, loss fn would be coming in, right? um, so this is loss fn would come in basically here, and it will be passed to this guy here, loss fn. Okay, and it will return the actual calculation will happen here, like return something and then return here. So as soon as you are hitting, as you are calling this line, basically it's returning a callable function. That is again, if now if we use this loss underscore fn, we can actually do the calculations as a callable function. We can use it. Okay, and that's it. I think you will see these kind of things well while studying closures and decorators in Python. I highly suggest you what to understand what they are and how they function, and look into what higher order functions are in Python. Okay, okay. So this is our first creation of our basic loop, training loop for PyTorch, and you see. So setting it to a training mode, I personally seriously do not know what exactly it does, but it's recommended by the PyTorch community, so I just use it. There's also evaluation mode that you have every time you do inference. Basically, inference is getting the predictions out right after the training happens, and you have saved the model. So to get those inferences and those predictions, you open the model in a eval mode. So that's something you want to keep in mind. Okay. So now we are doing a forward pass. Okay, we have this, and let's do the forward pass. We did the forward pass. Now we can actually go and see everything here. Okay, so we have the debug console on the bottom left corner. Okay, so let's see the actual data set. This is how it looks. Let's see the shape of it. Again, it's 80 cross 1, which is what we have done, right? We have done this, and let's see what y hat looks like, right? Y hat looks like, y hat looks like something like this. Okay, so every single sample, so y hat, I can also see the shape of that. It's supposed to be 80 cross 1. Yes, it is 80 cross 1. So every single input from your x-train tensor is giving out one output into the y hat function, right? Y hat variable is storing all the outputs, right? Now let's see the loss. So as I told you, this dude is callable, right? This dude here is callable. You can see that how it's defined like this. Also, you can see it was calling it. That dude is callable. I'm gonna run this. I'm passing in y hat, that is the prediction, and the actual values from the data set that we have. Okay, so you see loss has been generated. Let's see what loss is, right? Okay, you see the loss has been generated for all the 80 samples that we have. Okay, we are not doing any batch training or anything. We are putting all the data in, all of the 81 of them, and getting in the output, and then calculating error, getting the mean. That's it. That's what we are getting here in the loss. And if you see, actually, I will also want to show you something. Like if you see loss function, the actual function, it is just a function. Okay, so you can actually, it is a callable function. It does not give out anything. Okay. So this is basically something that you want to monitor. If you want to monitor, basically what I'm trying to do here is, uh, so model dot named parameters are where all the parameters and their names are stored. For example, you see here also I have passed that in, right? The parameters, actual parameters of our models are stored. So I can show you what it is basically, right here. So we have two parameters, that is weights and biases, and for the and it's just have one neuron. Like the first layer would be 0 and second layer will be 1. So you can see that coming in action. I will do that. If not none, it is none right now, so it won't go inside, but that's fine. We'll get to see that later. Okay, it's going through all of them. So it did two times. If you notice, they went two times. That is because of the weights and the biases. So weights is one and the bias is one. Okay. Okay. There are only two parameters in our model right now, right? uh this one also, uh okay, if there is a grade, the gradient only it will work, right? Okay, it's trying to do that. Okay, then we did is hit the background. So what is it? Compute the gradient for both a and b. So right now we have gradients. I can right now show you what it is. Let's take this code and put it here and see for ourselves. Enter. So you see epoch 1, the first epoch that we have, the 0th layer, we have a weight and its gradient is this. We are keeping a track of the gradients, okay? And let's also see, uh, okay. Yeah. So you can also see for yourself the weights that are there, okay? And let's do a simple change in our code. Maybe we can make it a little more. What if we do values of the weights, right? So we can say is name is there, parameter is there. Let's print the parameter as well, right? Print the param. If we do that, it should work. Hmm? I'm sorry. What am I doing? Okay. Okay. Let's print the parameters as well. Okay. So you see, uh, so our parameters right now are, let's note it down just so that we have all the necessary values in our brain, right? We zoom it in a little bit. Okay. Okay. Too much. So the weight, or let's say W is what? It's 0.7645, and bias right now, that's B, is what? 0.8300, and the grad here, weight dot grad is minus 0.9465, and let's say B dot grad is what? Minus 1.5251. Okay. Okay, let's do this. So now you have calculated the gradients for both the parameters. Now we are going to do the step function, basically the updation. So basically updation would be like, see, I have set all the numbers already. I know the learning rate is 0.1. The formula for updation is what? The old weight, basically the old, or I can write it down. The old guy would become what? It would become the, sorry, I'm so sorry. So the new guy will be the old guy minus the learning rate into the gradient. So here it will be w dot grad. You can actually make these calculations. Okay. So for example, old guy, old is what? This guy, right? That we have. So 0.7645 minus 0.1, that is the learning rate, into the gradient, that is minus of 0.94, 6.5, and whatever the answer is, let's see what the answer is, right? All you have to do is go and click on this step. It did the updation, and if I run the same code again, okay, you will see the values are changed. Now what is the answer? So basically this answer should be essentially 0.8592. That is exactly what you get after multiplying all that. So you can actually see what's happening. The actual the initial value of the weight was 0.7645. Now the value is 0.8592. So you actually see the change, right? It goes from here to this guy. Wait, let's change to this, from this. So does bias. Bias of the same formula will go. Only thing will change is the omega will change to b, w equals to b old minus again the learning rate grad. Okay, learning rate are represented by like this. It's basically the learning rate, okay, which is equals 0.1. Cool. Yeah. Okay, now that our model has all the necessary parameters, okay, I'm gonna do this also here, put it all in, and let's parameter values are also being taken in. Cool. Or what you can do is actually you can also see like this model dot state. You see that state, you can see exactly the values inside like this also every time if you just want to see the state of the model. And you can also go into one of the, like you can see dot, let's see, you just want to see the weights, you can just see the weight like this. So all that stuff is everything is stored here. Even optimizers have a state, they also keep it there. Okay. Cool. So if you want to see and monitor basically the what do you say, the state of your model, how are things changing and all that, and you can see for yourself. Okay, now after everything, the updation has happened, the using the gradients. And one thing that's probably the most thing, there's a saying that you don't merely just update weights in your neural network, right? You also have to empty your gradients. Basically, if you don't do that, the accumulation, basically every time it will accumulate the gradient that was calculated, it will add to the previous gradient and previous gradient. We don't want that. So let's zero out our gradients. So if you see now, if I do the same thing, okay, let's see. Okay, see, you don't see nothing here. As soon as I hit one more, see, nothing is there. You don't see any outputs, right? Everything has been emptied because the gradient is actually none. Here the gradient is actually none. If you actually you can also, I can show you how. I can go here and just print this out. Print param print what I should do is name and param dot grad. If I do that, you will see both of them have none values. Basically nothing is there in the gradient now. Cool. Let's go on. So the first loop, one loop has been completed. So epoch in a sense means, so we are setting epoch as 1000. What does it mean essentially is we will go through the complete data almost 1000 times. Exactly 1000 times in this case, right? So we will go through all of data 1000 times and we're going to do 1000 updates. In this scenario, we are not doing any batch. For example, we are not batching our whole data set, that is 80 instances of our data into batches of, let's say, 20 20 20, and we have 4 batches like that, right? And with every batch there's update. So every time, remember one thing, I always get confused in this what do you say, this process of looping, is that one thing you have to remember is epoch means one epoch. When someone say one epoch is completed, that is they have done all the forward propagation and the updation and everything on the full data at least once. So once they have went through the all data, right, and then they have made the uh, update the parameters. So in the epochs there can be batches, and every batch can have their own updates. Okay, so let's frame it a little bit, because these things confuses me sometimes. So what do you have? Epochs. Epoch is going through the whole data. Okay, and now there are batch. So batch is basically one batch complete, one update is done. So you can create, for example, so it's like a subset of this dude. Okay, it goes inside it. Hmm? So you have a training data set of 80. Okay, you are not doing any batching, so one epoch means you did go through all the data points and had a single update to the parameters. Okay, in this case w and b, weights and bias. Okay, but if you had batch, if batch is there, then what you do is you have a epoch loop that goes, then inside there you have a batch loop also going on. Okay, so let's say the batches of 20 is there, so every batch has 20 data points, so it will be like 20. First batch will have 20. Okay, and the second batch will have 20, the third batch will have 20, and the fourth batch will also have 20. So once it's done, so basically it goes from 0 to 19, let's say, and indexing basically, or for our better understand, just say goes from first point to 20th point, and it does an update. Okay, then again the loop goes on, and then it goes on and do 21 to 40, and then update. Sorry, so on. And once all the basically it's done, and it's from what 61 to 80, right? And then one more update is done, and then the loop comes out and goes to the, so basically now one epoch is complete here in this case. Okay, it's important to keep this in mind. So if I am setting epoch 1,000 times, so it will do this 1,000 times. Hmm? Cool. Yeah, um, a little digressed, but I guess it's an important point. Let's go on. No, this is the second loop. The epoch is 2 at this point. I can also show you what it is. So you can see here number of all the parameters. It's too big, that's why I'm not showing you the call stack and all that stuff. Uh, yeah. Uh, okay. Model is trained, y hat is computed. So you can see the y hat is here, y eval, all the necessary things. So this is the second loop that we are going on. Epoch is 1, basically 0 and 1, indexing from 0, right? And again it goes on and goes on. See, now it will actually print as the gradients are 0, it won't print anything. But now you can see each will see for itself. Does it have anything? No. Actually, it won't work anytime because the gradient will always be 0 if I put it here actually. But it will work if I put this code here. I mean, if I change the whole code like this. I took this and put it here. This would work, but as I'm in the debug mode right now, I don't want to do anything. Okay, cool. Um, cool. Again, the done is done. Deal is done. Basically, let's see what the parameters are right now. So, oh, I have already made the update, right? Sorry. Let's do it once more and let's see how the gradients are changing. Done. Stepping in. Okay. before we empty the bucket of gradients. Let's do it. So in the third epoch, we are getting W as 0.99, which is almost to the true value, right? The true value here is what? True value is uh, true value of B is 1 and W is 2. Okay. So we are getting to that point. We are slowly moving there. So I'm just gonna hit this so that we are done with the whole loop 1,000 times. Okay. We are done with it. Okay. Let's see if this thing still works. I don't know. No, because everything is emptied, right? So now if we actually I can see one thing simply. Can go here and do this model state. Now you see the W is 2 and bias weight is 2 and the bias is 1, which was exactly what our true values were. I mean, we are approximating, right? So you can see the model has been trained. Okay, let's get on with better approach to the whole thing. Now we are getting into a little bit more advanced things. So I was talking about higher order functions, right? So this is what we call a higher order function in a sense. Okay, as you can see. Cool. So what is higher order function in a sense is there's a function inside a function. So you are making training steps and performing training steps inside it. So every time if I call this function, it will return this function and I can pass in the data set. So what is the big the outer function taking in is the model that you have, the loss function and the optimizer that we have already stated here. The models, the optimizers and the loss function that we already initialized, this function just will take that. Okay, and every time if you want to perform the training, all you have to do is pass in the uh, x and the y, that is x train and y train in our scenario, right? Okay, so everything is similar to the model is being trained. It's in the train mode and the forward propagation is done, calculating the loss, calculating the gradients of both a and b, updating the parameters using gradients, and then 0, and then also what only thing that we are returning here is the loss. Okay, so this is what we are gonna need. So loss dot item is used because I feel I'll show you. If I say loss, you see this, right? It's a tensor. We don't want that. We actually just want the number, right? So what you can do is simply do this items and you will just get the exact number. Okay, so that's what happening here. Cool. Initializing the functions. Okay, again we are doing the same thing. Only thing is I think different from here, nothing is different, right? So we're just calling in the actual parameters because again we have to initialize the model, right? Because our model has the previous model was already been trained, right? So we are initializing a new model. Everything is set from 0. All the parameters are 0 now. You can also check it out. For example, you can see models. I can just use it. See, now everything is set back to the initial stages, right? The exact numbers. Cool. Uh, Again, the only difference you see here right now, I don't know if you, okay. So you had 3 of them initialized and you are passing that into the make train make train step function. You're going inside here, right? You're passing in that and now see what it will return. It will return the the function that was inside there, right? It is returning the function that was inside there. So now this train step function is a callable function. Okay, so let's do training. Simple. All you have to do is essentially define the epochs, how many epochs you want, how many times you want the model to go through your whole data, and also store the loss somewhere, right? That's it. Epochs and loss is done, and we are starting off. You can see what's going on inside. So as I told you, this function is a callable now. I can pass in the x train and y train, and let's just go inside. Again, the first epoch is going on, it's doing its thing, returning the value, and loss is calculated. So now you can see the model state has changed, the values are also changed, and loss is there, some calculated. Okay, if you want to see the other factors, I mean, it will be 0 because I have emptied the whole thing. Cool. Next epoch, again, let's go through it, and done. So let's see what's the value here now. Okay, you see things are going on and on. I am gonna step over them and just show you a few things after, let's say, 3-4 epochs. Okay, the things are moving, and I am gonna do all the 1000 epochs at once. Done and done. So now I can see the model state. We are getting the same values that was supposed to get from the previous model, which is exactly the values from here. So we created basically a wrapper function over the training sets, training model basically. Cool. So we are getting to the new and a better way to do things here. So we are starting off with a module called dataset, which comes from PyTorch itself. So you can see this is a PyTorch's implementation. So it's a very useful tool to have to format your uh, dataset, because you have dataset of all sorts with all types, right? And you want your PyTorch to be very what do you say, compatible with the dataset that you have, and you want to make those dataset compatible with PyTorch. So how PyTorch handles data, right? So this is what dataset is, and we are going to use it now. Okay, so this is basically a custom dataset that we are creating. It's a class, and we have something that will do the exact same thing. We'll see it in the future. So what we have here is a custom dataset, and how it functions is basically you have initialization. You are initializing what? The X train and Y train in a sense. Okay, so X and Y that you have, and you have get items. So get items is a dunder method. uh, Basically it every time you do the indexing on any array or uh, any list, so this is what actually gives out that value. Okay, list um, 0, list 1, list 2, like that. So this is what it does. So basically we are overriding it uh, with our own logic. So basically this is comes under the polymorphism topics of OOPS. So if you are not familiar with OOPS, it will seem a little awkward. What is this all things? But if you are, then it's all good. So look up polymorphism in Python, how it's done and all.